So today we're going to be doing May-June 2024, paper 21. It's paper 2, variant 1. Choose from the following substances to answer the questions. Each substance can be used once, more than once, or not at all. State which substance is a catalyst in the Haber process. That would be iron. Okay. Haber process is when nitrogen and hydrogen react to form ammonia, right? Iron catalyst is used. Okay. Has a giant covalent structure, silicon 4 oxide, right? That's just sand. Has a macromolecular structure, a giant covalent structure, also known as silicon dioxide, silicon 4 oxide, or silicon dioxide. Changes from blue to white when heated. That would be hydrated copper 2 sulfate, right? If you guys remember, hydrated copper 2 sulfate is CuSO4.5H2O, right? That's a blue, those are blue crystals. And when you heat it, you get anhydrous copper sulfate. You get anhydrous copper sulfate, which is white, right? And this is also used as a test for water, right? So used as a test for moisture, because if you add water to the anhydrous copper sulfate, it turns blue again. Yeah, it's used as a test for moisture. So this would be hydrated copper 2 sulfate. Removes tastes and odors during the treatment of the domestic water supply. We use carbon to remove tastes and odors. Okay, pure carbon, which is given here, right? Has the empirical formula CH2O. So we're looking at an organic compound, right? Methanol is CH3OH. So the empirical formula is CH4O, right? The molecular formula and the empirical formula is CH4O. So it's not methanoic. It's not methanol. Methanoic acid is HC double bond OH, right? So that has the empirical formula CH2O2, right? CH2O2. That is also not the answer, right? Because methanoic acid has the empirical formula CH2O2, right? One carbon, two hydrogens, two oxygens. Glucose is C6H12O6. The empirical formula is C. If you divide everything by 6, right, you get CH2O. Okay, you get CH2O. So that would be glucose. Calcium carbide reacts with water to form a flammable gas ethyne and calcium hydroxide. Construct the symbol equation. Symbol equation just means the regular chemical equation for this reaction, right? Using the formula. So we got calcium carbide, which is CaC2. It reacts with water, that's H2O, to form C2H2, right? To form a flammable gas ethyne and calcium hydroxide. Calcium hydroxide is CaOH2. Okay, calcium 2 plus, and then OH hydroxide is 1 minus, right? So that would be CaOH2. Okay. And then to balance this, right, we're just going to look at the oxygens. We have two oxygens here. So we're going to say 2H2O. And then we have one calcium. We have two carbons, right? We have 2 times 2, which is 4 hydrogens. And we have 2 and 2, 4 hydrogens. And we have 2 oxygens. So everything is balanced. All right, so this equation is balanced, right? Because we have 1 calcium, we have 2 carbons, we have 4 hydrogens here, and then 4 hydrogens here, and then we have 2 oxygens, right? Calcium carbide is ionic. Deduce the formula of the carbide ion. So they've given us the formula, which is CaC2, right? Now we know that calcium is 2 plus, right? Calcium is 2 plus, which means that the entire C2 thing is 2 minus. So C2, 2 minus, right? So that's the formula of the carbide ion. Okay, C2, 2 minus. Figure 2.1 shows the displayed formula of ethyne. The ethyne is unsaturated. Why is it unsaturated? Because, explain why ethyne is a hydrocarbon first, right? It only contains carbon and hydrogen. Only contains, or contains carbon and hydrogen only. And then why is it unsaturated? Because it has a triple bond, right? So again, saturated means all the bonds are single bonds. Okay, all the bonds are single bonds. Here we have a triple bond, so contains a triple bond, right? Or you can say not all bonds are single bonds. Okay, contains a triple bond, or not all bonds are single bonds. Aqueous bromine reacts with ethyne. Predict the color change that happens. Similar to ethene, guys. If you guys remember, for alkenes, aqueous bromine is a test for the double bond, right? And the observation is orange to colorless. Okay. Some places will also say brown to colorless, but aqueous bromine is more accurately orange. Okay. For iodine, it's brown. For bromine, it's orange. So we're gonna say orange to colorless. Okay. Right, or decolorization of aqueous bromine. Draw a dot and cross diagram to show the electronic configuration in a molecule of ethyne. Okay. Molecule of ethyne. So what do we have here? Well, we have a triple bond. Let me draw this out again. We have a triple bond and two single bonds, right? So again, carbon has 4 valence electrons. All of them are bonded. Hydrogen has 1 valence electron. It's bonded, right? So there's no electrons that are unbonded. No valence electrons are unbonded. So we're gonna say carbon. So we got carbon, carbon, hydrogen, and hydrogen, right? Like that. And then what do we have? We have a triple bond. Remember, each line represents a pair of electrons. The triple bond means we have 3 pairs of electrons. That's 6 electrons. Okay, so that's carbon, carbon, hydrogen, hydrogen. We have a single bond between the carbon and the hydrogen, single bond between the carbon and the hydrogen. The equation for the complete combustion of ethyne is shown. Complete combustion means you form carbon dioxide and water, right? If you have a hydrocarbon, the reaction is exothermic. Explain using ideas about bond breaking and bond making why this reaction is exothermic. Again, remember, if it's bond breaking is endo, right? It's positive. Bond making is exo, right? It releases energy. Bond making requires energy. Bond making releases energy. Okay. Bond making releases energy. Bond breaking requires energy. Requires energy means energy is put in, taken in, endo. Releases energy means energy is given out, exo, negative, right? Now, if the overall change is exo, that means enthalpy change is negative, right? And that means that the bond making part, the bonds that are being made are stronger. Okay, bonds that are being made are stronger, right? So we can say that more energy is released. Okay, more energy is released when bonds are made. Okay, bonds are made. That's in the products. So that's the products, right? So the bonds made are stronger, right? So more energy is released when bonds are made than the energy required or needed, to break the bonds of the reactants. Okay, this is in the reactant. You guys can also just use the equation, right? Enthalpy change is bond energy of reactants minus bond energy of products, right? If the overall change is negative, right? If the overall change is negative, right? Let's take an example. Let's say this is 80 and this is 100. Overall change is negative means bond energy of products is greater. Bond energy of products is greater, so you get negative 20, right? In this example, I was using example values, right? So, whereas if reactance was greater, then it would be endothermic, right? Then it would be endothermic because you get a positive enthalpy change, okay? So, bond energy of products is greater. That means more energy is released when bonds are made, okay? Because reactants are the ones that are broken and products is the ones that are made. Complete the reaction for the complete combustion of ethyne. Label the reactants, products, enthalpy change of the reaction, and the activation energy. You have an exothermic reaction, right? Because it's combustion, which means that the reactants are higher than the products, okay? Now, just a reminder that this is your, so यहाँ पर आपके reactants होंगे, okay? You have to write down the reactants if they've given it to you, right? You've got 2C2H2 plus 5O2 balanced. So you got 2C2H2 plus 5O2, right? And then you have, for the products, you have 4CO2 and 2H2O, okay? 4CO2 and 2H2O. All right. Your enthalpy change is negative, right? This is your enthalpy change. Enthalpy change ka arrow will be downwards, right? Because it's exothermic. So from the reactants to the products ka level, from the reactants to the products, okay? From the reactants to the products. You can also draw a dotted line if that helps. Right, like that. This is your enthalpy change. Okay, this is delta H. And your activation energy is from the starting point to the peak. Always be an upward arrow. It'll always be an upward arrow. Sorry, it's a bit off. That, and then this is your activation energy. Okay. So that is a correctly labeled diagram. Okay, 1 second. This line is going a bit data. Yeah. Aqueous ammonium nitrite, that's this guy, decomposes when heated to form nitrogen, right? Decomposes just means one thing breaks down into other things, right? It's the opposite of addition. Addition is when multiple things combine to give you one thing. Decomposition is when something breaks down to give you multiple things, okay? A 25 cm cube sample of 0.133 mole per dm cube, just always highlight or underline the information given, is completely decomposed. Calculate the volume of nitrogen formed. That's what they want us to find. Also mark that. Two significant figures. Okay. Right. This is at room temperature and pressure. Okay. So for mole calculations, again, just remember first step, convert the known quantity to moles. The known quantity is the concentration and the volume of this guy. It's a solution. So N is equal to CV. Concentration is 0.133. The volume is 25 over 1000, right? Has to be taken in dm cube, given in cm cube. So we get 0.133 times 25 over 1000, which is 0.003325, 0.003325 moles. Okay. Then second step, find the moles of the unknown quantity, which is nitrogen. That's what we want to find. So it's a 1-to-1 ratio. 1-to-1 ratio, I'll write that down. We have NH4NO2 to N2. 1-to-1 ratio. So if we have 0.003325 moles of this, how many moles of nitrogen do we have? 0.003325, right? So it's a 1-to-1 ratio. And then lastly, We can find the volume in decimeter cube. That's what they wanted. Look at the units. Room temperature and pressure. The volume of a gas is number of moles times 24, right? If you want to find it in dm cube. We just do 0.003325 times 24. So you get the volume as 0.080 decimeter cube. Okay, because you wanted to two significant figures. I'll tell you what you get. So you get 0.0798 dm cube. So they want the answer to two significant figures. Remember, the first two zeros are non-significant. Leading zeros are insignificant, right? Not significant. The first non-zero digit is the first significant figure. You're going from left to right. The first non-zero digit is the first significant figure. So one significant figure, two significant figure. Okay, so two significant figures are going to round here. So this will become 79 will become 80. Okay, so volume of nitrogen is 0.080 decimeter cube. Describe and explain the effect of increasing the temperature on the rate. Rate increases, right? Why? Because as the temperature increases, the velocity or speed and kinetic energy, I'm just using KE for kinetic energy, okay, of the particles increases. You guys should write the whole thing, okay? Kinetic energy. Kinetic energy of the particles increases. Hence, more particles have energy greater than or equal to the activation energy, right? Because again, this is the energy needed for them to react. You have more particles that have the minimum energy. You have more particles that have that energy needed to react, okay? Pehle, you had lesser particles that had the energy needed to react. So more particles have energy greater than or equal to the activation energy. Hence, frequency of successful collisions increases. Again, a successful collision just means results in a reaction. So you have more reactions taking place per unit time. Describe and explain the effect of decreasing the concentration of ammonium nitrate on the rate. Rate decreases. Always just state it first. Okay, rate decreases. Okay, why? Because fewer particles are present per unit volume, right? Concentration decreasing. Concentration kya hota hai? Concentration is number of moles per unit volume, right? Right? If you're decreasing the concentration, it's the same as saying you have fewer moles, right, per unit volume. So fewer particles present per unit volume. If you have fewer particles, right, in the same space, you're going to have fewer collisions, okay? So fewer particles per unit volume, right? Hence, essentially the distance between the particles increases, right? Distance between the particles increases, and as a result, you have fewer collisions taking place. Hence, frequency of successful collisions decreases. One way to measure the pH is to use a pH meter. Describe one other way to measure the pH. We can use an indicator, specifically an indicator that approximates the pH, which is universal indicator. Okay. Use universal indicator. If you remember, the universal indicator has the colors of the rainbow, Roig Biv. Okay, red is acidic, strongly acidic, and then the blue end is violet, is basically alkaline. Okay, so the more red it is, the more acidic. Green means neutral. Green means neutral, right? So acidic means lower pH, alkali means higher pH. So you can look at the color, right? Let's say you got something like an orange and compare it to a color chart. Okay, the color chart will basically, you can compare the color you got. You can compare the color you got to the color chart that will approximate the pH. Okay, because color chart pe pH likhi hui hogi, approximate. The color chart will tell you, hey, this color means this pH approximately, right? So use universal indicator and compare color to a color chart. Okay. Specifically, it's called a pH color chart. Okay. To a pH color chart. Okay. And yeah, so compare it and then match the pH, right? Okay. Potassium iodide is an ionic solid composed of a lattice of potassium and iodide ions. Explain why potassium iodide has a high melting point. Why? Because you have strong electrostatic forces of attraction, right? Ionic bonds, basically. Strong electrostatic forces of attraction between cations, right, which are positive, and anions, which are negative. Describe how potassium atoms and iodine molecules react to form potassium ions and iodide ions. Use ideas about electron transfer. Let's write down the equation. Potassium reacts with iodine. Iodine is an element to form Ki, right? Potassium reacts with iodine to form Ki, right? And this would be 2 here, right? And 2 here. So if you guys remember, potassium is in group 1. It forms 1 plus ions. And iodine is in group 7. It forms 1 minus ions. Okay. You can take a look at the periodic table. Potassium group 1 forms 1 plus ions. Iodine is in group 7, forms 1 minus ions. Right? So we can say that what's happening here, right? Essentially, one way to think about it is that, because they're talking about iodine molecules here. Each iodine molecule has 2 iodine atoms, right? So we can say that you have 2 potassium atoms, right? 2 potassium atoms lose an electron each. Okay, 2 potassium atoms lose an electron each to form K plus, right? And each of the iodine atoms, each of the two iodine atoms in the molecule, right? Each of the iodine atoms in I2 gain an electron, okay, to form I minus. Okay. Predict the products at each electrode during the electrolysis of concentrated aqueous potassium iodide. Okay. Again, potassium iodide, you have concentrated aqueous, right? Concentrated aqueous. So again, cathode is always hydrogen. The product is always hydrogen, except when you have copper, silver, gold. Okay, right? Always hydrogen. So H plus Remember, H plus will gain electrons at the cathode to form hydrogen. Always, unless you have copper, silver, gold. Okay, we don't really even see gold, so copper or silver basically. So cathode pe, the product is going to be hydrogen gas. Okay, and anode, dilute is always oxygen, and concentrated is halogen. Okay, concentrated is halogen. So in this case, we have concentrated, so we're going to get the halogen, which is iodine. Okay. So iodine and hydrogen are your products. Iodine is I2, hydrogen is H2. Okay. Aqueous potassium iodide reacts with aqueous potassium manganate 7. Suggest the color changes. Okay. Now, if you guys remember, iodide is a reducing agent. It's a reducing agent. It forms iodine, right? Which is brown in solution, which is brown in aqueous solution, right? It is brown in aqueous solution. And manganate 7 initially is an oxidizing agent. It's purple and it turns colorless. So initially you had iodide, which is colorless. Okay, you had iodide, which is colorless, and you had manganate 7. So initially the mixture was purple. The final solution has iodine and the manganate has turned colorless. So the iodine causes it to be brown. So the color changes are purple to brown. Okay, purple to brown. I'll repeat this. You're starting with iodide and manganate, which is purple. They react with each other because iodide is a reducing agent and manganate is an oxidizing agent. So iodide reduces manganate, manganate oxidizes iodide, right? So what happens here? Iodide turns to iodine, which is brown, and manganate goes from purple to colorless. So the final solution is colorless and brown, which is obviously going to be brown in color. Okay. The ionic equation for the reaction between aqueous potassium iodide and aqueous chlorine is shown. In terms of electron, why does this reaction involve both oxidation and reduction? So I minus loses electrons and undergoes oxidation, right, to form I2, right? I minus is making I2. So it loses electrons to form I2, right? It's a reducing agent, undergoes oxidation. And then chlorine gains electrons to form Cl minus, right? So it undergoes reduction. Cl2 gains electrons and undergoes reduction, right? You have to mention the oxidation and the reduction part to form Cl minus. Okay. You can also use the names. This would be iodide. The anion is ide and iodine. And this would be chlorine and chloride. Okay. Right. When a sample of zinc sulfate is heated in a closed system, an equilibrium mixture is formed. The forward reaction is endothermic. The temperature of the closed system is increased. So forward reaction is endothermic. Let me write that down. So delta H is positive. Endothermic means delta H is positive, right? Temperature of the closed system is increased and the pressure is kept constant. So all you're doing is increasing the temperature. Okay. Predict how the position of the equilibrium of this reaction is affected. Okay. Increase in temperature favors the endothermic direction. Why? Because you have more heat. Endothermic reactions take in heat. Endothermic reactions take in heat. The forward reaction is endothermic. Because you have more heat, it'll take in that heat and bring the temperature back down. Right? If you guys remember equilibrium, that the equilibrium moves in a direction to oppose the change. If you increase it, we want to bring it back down. How do we bring the temperature back down? How do we bring the temperature back down? By absorbing the heat. So to absorb the heat, it'll go in the endothermic direction. That's why higher temperature favors endo. Okay, we have to say that. So we're going to say that the equilibrium position shifts or moves to the right. Okay, they like to use the word moves. That moves to the right. Right, equilibrium position moves or shifts to the right. Right, since the forward reaction is endothermic. Right, forward reaction is endothermic. Right, and it absorbs that heat. Right, it absorbs that heat to oppose the increase in temperature. In other words, it brings the temperature back down by absorbing that extra heat. Whenever I say temperature, the temperature, even when we talk about the closed system, right? A closed system means that your reaction is taking in heat, और उसके इर्द गिर्द temperature को क्या हो रहा है? कम हो रहा है. Because the reaction itself is taking in heat, the surrounding temperature within that system is decreasing. We always measure the temperature of the surroundings, okay, even in the closed system. All right. The pressure of the closed system is decreased and the temperature is kept constant. Okay, so now we're decreasing pressure. We're decreasing the pressure. Okay, keeping the temperature constant. We predict how the position of equilibrium is affected. Increase in pressure favors the side with fewer moles of gas. Okay, pressure increase favors the side with fewer moles because it'll bring the pressure back down. Again, we want to do the opposite, right? The equilibrium will shift to oppose the change. If you increase pressure, it wants to bring down the pressure. If you increase it, it wants to bring the pressure down. So it'll go to the side with less gas because less gas means lower pressure. You're decreasing the pressure, you want to bring it back up. How do you bring it back up? Go to the side with more moles of gas. More moles of gas on the right. You have 0 here, you have 1 here. Right? So the equilibrium will shift to the right. Okay? So equilibrium position moves to the right. Okay? Equilibrium position moves to the right. Okay. Why? Because as a decrease in pressure, favors the side with more moles of gas, right? So then the pressure will go back up. Moles of gas. There's 1 mole of gas here, gas, only gas, not all moles. How many moles of gas are on the right? 0. Do not count the solids or liquids. You're only looking at gases when we talk about pressure. Okay. So we just have to look at the gas, like kitne moles, and look at the coefficient. 1 here, 0 here, right? This is solid. Okay. So we can say that equilibrium position moves to the right as the decrease in pressure favors the side with more moles of gas. Okay. And if your gas increases, your pressure will go back up, right? So this opposes the decrease in pressure. Okay? To oppose the decrease in pressure. Okay. Or you can say to increase the pressure again. Okay. Always make that statement to oppose the whatever you did. So in the first one, you increase temperature, so you want to oppose that increase. Here you decrease pressure, so you want to oppose it. Okay. Calculate the maximum mass of zinc oxide that can be made from 25.5 grams of zinc sulfite. Okay, so we're going to take this and copy this, paste it right here. Okay. So they've given us the mass of zinc sulfite, right? 25.5 grams. Okay. and they want to know what the mass of zinc oxide should be. Maximum just means assume it's 100% yield. So just assume that the reaction goes to completion, right? Not reversible or anything. Just assume that it's going fully, right? Like how much theoretically should you get? So just like a regular mole calculation. The first thing again is to find the moles of the known quantity, right? So the first thing is we're going to find the moles of this. Number of moles is mass over molar mass. Mass is 25.5. The molar mass is zinc is 65. Okay, you can check from the periodic table. Zinc is 65 mass, sulfur is 32, and oxygen is 16. Okay, so we have 65 plus 32 for sulfur, and we have 3 oxygens. So 3 times 16. Okay, and then you get the, so this becomes 25.5 over 145. Okay, 25.5 over 145, which is 0.1759. 0.1759 moles, right? All right, so we have the moles of zinc sulfide. Now, just use mole ratios again. Second step, use ratios to find the moles of the unknown. The unknown is zinc oxide, right? So second step, we have a 1-to-1 ratio, ZnSO3 to ZnO, right? So if you have 0.1759 of this, you'll have the same of zinc oxide, 0.1759 moles. And then the third step, convert the mass. This would be mass is number of moles times molar mass, which is 0.1759. 0.1759 times 65 for zinc and 16 for oxygen, so times 81. So that gives you 14.2 grams. Okay. The mass of zinc oxide is 14.2 grams. Zinc oxide reacts with both aqueous sodium hydroxide and dilute hydrochloric acid, where sulfur dioxide only reacts with aqueous sodium hydroxide. Why? Reacts with both alkali and acid, right? So zinc oxide reacts with both alkali and acid, which means it's amphoteric. Okay, amphoteric means that it reacts with both. So ZnO, or you can say zinc oxide, is amphoteric, right? Hence it reacts with both acid and alkali, right? Whereas sulfur dioxide is an acidic gas, so it only reacts with alkali. The solid zinc sulfide reacts with dilute nitric acid to give sulfur dioxide gas and aqueous zinc salt and colorless liquid. Construct the symbol equation. Again, symbol equation just means a regular chemical equation with state symbols. Okay. So zinc sulfide is ZnSO3. That's already given to us in the question, right? Zinc sulfide is ZnSO3. Okay. So we have ZnSO3, right? It says solid zinc sulfide. So solid reacts with nitric acid. Nitric acid is HNO3. Acids aqueous, right? To form sulfur dioxide gas. Okay, that's fine. And then we get a zinc salt. So remember, how do we get a salt? The cation from the solid and the anion from the acid. So zinc nitrate. Zn is 2 plus and nitrate is 1 minus. That would be ZnNO3 2. Okay, ZnNO3, the whole thing 2, right? A bit to the right. ZnNO3 2 would be aqueous. Okay, it will be aqueous because it says aqueous zinc salt, and you should know that all nitrates are soluble. all nitrates are soluble from the solubility rules for salts. And then the remaining product will be colorless liquid, would be water. Why water? Because you have hydrogens and oxygens to deal with, right? Nitrate तो यहाँ पर है, but SO2 में एक oxygen कम हो गया ना SO3 से. So one oxygen, you also have these hydrogens, so you're gonna get H2O. You have to balance this H2O liquid. Okay, H2O is a liquid, colorless liquid. Okay, and now to balance this, right, you can start with the nitrate, right? So nitrate would be, don't start with like something like oxygen or something, because that would be very complicated because you have multiple places where the oxygen is, right? Start with nitrate because you can see the whole thing here becomes that, right? Sometimes you have to look at the entire thing instead of just atoms individually. So you have one nitrate here, you have two nitrates here. So that would be 2HNO3. Okay, then you have, that's it, the rest is balanced. You have one zinc, you have one sulfur, right? You have two hydrogens, right? And then at the end, you have two nitrogens, right? Two nitrogens. And then lastly, you have 3 plus 2 times 3, that's 6, 9 oxygens. And here you have 3 times 2, 6. Wait, not 9, sorry. 2 times 3 is 6. Oh, yeah. And here you have 2, and then 2 times 3 is 6, and then 1. So then you have 2 plus 6 plus 1, that's also 9 oxygens. You can also double check the atoms at the end just to make sure that you have it correct. Carbon dioxide is a greenhouse gas that is linked to increased global warming. Describe one adverse effect of increased global warming. Okay, climate change. Climate change is different from global warming. Global warming is just the fact that the earth is heating up, and climate change is a result of that, right? So like bigger storms and more frequent floods and more heat waves, right? Those are how that basically tells you how more extreme seasons, right? Those are the effects of global warming. Okay. Describe how carbon dioxide causes global warming. You guys should know that carbon dioxide, how does it cause global warming? So excess, when you have a lot of carbon dioxide from man-made sources, right? Excess carbon dioxide absorbs thermal energy, right, or heat. Thermal energy, okay, that is thermal energy from the sun, right, as well as thermal energy that is reflected by or emitted from the earth, right? So basically some of the heat energy is reflected back into space by the earth. Some of the heat energy, right, when energy comes in from the sun, some of it is reflected back, or some of it is absorbed by the earth and then emitted. Emitted means it's absorbed and then released. Emitted means it's absorbed and then released. Emitted means released. And some of it is reflected. Now it doesn't go back into space because the carbon dioxide in the atmosphere absorbs it, which means that the atmosphere heats up. Okay, so thermal energy that is reflected by and emitted. Okay. Thermal energy that is reflected by and emitted from the earth, right, is also absorbed, right? So as well as thermal energy. Yeah, so it absorbs thermal energy from the sun as well as thermal energy that is reflected by and emitted from the earth, right? And as a result, it causes it prevents it from reaching back into space, preventing it from going back into space, right? Which means it's trapped inside the atmosphere. So the atmosphere heats up, okay, to space, right? So it traps it. traps heat essentially, right? Photosynthesis removes carbon dioxide from the atmosphere. Write the word equation. Word equation for photosynthesis is carbon dioxide reacts with water to produce glucose plus oxygen. Okay. And describe the conditions that are needed. You're going to need sunlight or light. Okay. Um, you're going to need light and chlorophyll, right? So light energy. Okay. That could be from the sun or artificial, and chlorophyll, right? Or something to absorb the light, which in plants is chlorophyll. Okay. Explain one strategy to reduce global warming caused by carbon dioxide. Just use fewer fossil fuels, right? So that's one way to do it. Right? Decreased use of fossil fuels, right? Or you can replace the use of fossil fuels with renewable energy, right? Decreased use of fossil fuels, right? Or you can use renewable energy instead, right? Of fossil fuels. Or you can plant more trees, right? Right? Replace fossil fuels with renewable sources. Okay. Chlorine is a gas at room temperature. Iodine is a solid at room temperature. A sample of chlorine has a volume of 240 cm cube at room temperature and pressure. The pressure of the sample is increased at room temperature. Okay, so you basically keep the same temperature, but you increase the pressure. You increase the pressure. Okay, the pressure of the sample is increased. Okay, that pressure of the sample is increased. Okay, so then the question is, what is the question? Describe and explain in terms of kinetic particle theory what happens to the volume. Well, if you increase the pressure, what happens to the volume? The volume decreases, right? Imagine a syringe, right? Imagine a syringe that's sealed from the top, right? If you push the plunger, right, you're going to decrease the volume, right? Now, why can you decrease the volume? Because when you pressurize a gas, there's a lot of empty spaces between the gas molecules. There's a lot of empty spaces between the gas molecules. When you increase the pressure, you basically push those gas molecules closer. So the same, because there's a lot of empty space, right? That's why gases are compressible. इसीलिए आप liquid and solid को compress नहीं कर सकते. Liquids and solids are considered incompressible because you can't decrease the volume because there's no empty spaces, right? Or barely any empty spaces. So we can say that the volume decreases. Okay, volume decreases, and the reason why is because the empty space between the particles decreases, right? Right, as the particles are pushed closer together. Okay. When heated at atmospheric pressure, iodine changes directly into a gas. So iodine is a solid that turns into a gas without becoming a liquid. Describe the changes in particle separation, arrangement, and motion. Okay. and it says changes. So what it was to what it is. So पहले क्या थे? Particles were solid. Solid में they were close together, right? So they went from being close together to far apart, right? That's the separation, close together to far apart, right? Right. The arrangement goes from ordered, right? So separation is, you can say close together, or you can say tightly packed. It's the same thing. Tightly packed, right? To far apart in gas. Arrangement, man, they were ordered, right? Ordered because in a solid you have a lattice structure, right? Right. Ordered to random, right? Because now in a gas they're randomly moving around, right? And that describes the motion. Motion क्या होता है? Particles in a solid are ordered, they're close together, and they vibrate in fixed positions, right? So the motion went from vibrations, right? They went from vibrating in fixed positions, okay? They went from vibrating in fixed positions, right? To moving freely, right? Right? From one place to another, right? From one place to another. That's called translation. Okay, translation means they can move from one place to the other. In a solid, they can't move from one location to the other. They can just move in fixed position. Okay. At the same temperature, at the same temperature and pressure, the rate of diffusion of chlorine gas is greater than that of iodine gas. Okay, so rate of diffusion, right? The rate of diffusion of chlorine is greater than iodine gas, right? Chlorine gas is greater than that of iodine gas because chlorine gas is lighter. Okay, chlorine gas is lighter, right? Has a lower MR. Lower MR means it's lighter, so it can move around more freely, right? So Cl2 has a lower MR than I2, right? And then that's why, hence, hence the particles of Cl2 are moving faster, right? The symbol of an iodide ion is shown. Complete table 7.1 about this iodide ions. Okay, well, we have 53 protons, right? That's just the proton number. 126 is protons plus neutrons. So we do 126 minus 53, we get 73 neutrons. And then we have a 1 minus. So 53 electrons there, but because it's 1 minus, it's gained 1 electron, right? Neutral atom mein protons and electrons are the same. It would be 54. Figure 8.1 is a flow diagram about showing information about some organic chemical reaction. Okay. Compound A is one of the structural isomers of alcohol with the molecular formula C3H8O. State the name of compound A. Okay. State the name of compound A. Compound A is 1, 2, 3 carbons, so prop, carbon, carbon single bonds, so AN, and then alcohol on carbon number 1. Right? Carbon number 1, because kone pe, here or here. Yahan par bhi hoti is the same thing. Right? If it was here, it would be the same thing. Propan 1 all. Okay? Middle carbon pe agar hoti to propan 2 all. Okay? Middle carbon pe hoti to propan 2 all. Right? But this is propan 1 all. Okay. Draw the displayed formula of the other structural isomer. Displayed formula means all the bonds have to be shown. The other structural isomer is propan 2 all. right? The OH is on the middle carbon, right? Doesn't matter if you show at top or bottom, it's the same thing. Okay. Draw the displayed formula of ester B. Ester B is when ethanoic acid is two carbons, eth means two carbons, right? Reacts with propan-1-ol. Okay, so let's draw this out. So what do we have? We have CH3COOH. This displayed formula chahiye, so I'm just going to draw it out. We have CH3 C double bond O, right? If you guys remember, carboxylic acid loses the OH group, right? Carboxylic acid loses the OH, right? And if you remember, the C double bond O from the acid, this carbon, the C double bond O from the acid, bonds to the oxygen from the alcohol, and alcohol loses the H. So what do we have? We have CH3 C double bond O, CH3 C double bond O, and then this carbon will bond to this oxygen. This carbon will bond to this oxygen. So CH3 C double bond O, and then that will bond to this oxygen. I'm going to draw it like this. This comes from the alcohol, right? And then what do we have? This oxygen is then bonded to three carbons. This oxygen is then bonded to three carbons, right? CH2, CH2, CH3. So again, C double bond O from the acid, right? Acid loses the OH. C double bond O from the acid bonds to the oxygen from the alcohol. Bonds to the oxygen from the alcohol. The H is gone, but the oxygen is still bonded to this thing. CH2, CH2, CH3. So we have CH2, CH2, CH3. And just a revision, if you guys should know how to name this. This is going to be propyl ethanoate, right? The acid part first, prop, because alcohol part first in the name, three carbon alcohol, so prop, and then YL, prop means just three carbons, and then ethanoate, two carbon acid, ethanoate. Okay. Draw the structural formula of propanoic acid. Propanoic acid is three carbons, so CH3 structural formula means CH3, CH2, COOH. Okay. State the name and formula of compound D. Compound D. Okay. So propanoic acid is reacting with a metal to form a salt and hydrogen gas. Okay. Acid reacts with reactive metal to form salt and hydrogen gas. So we have, let me write down the equation. We have CH3COOH. CH3COOH reacts with magnesium to form what? Okay, first of all, remember the acid will lose this hydrogen, right? So you end up with CH3COO, right? But CH3COO is 1 minus. Magnesium is in group 2. It forms 2 plus. It forms 2 plus. So it'll be this 2 and then Mg. Okay, I'll repeat this. This guy is 1 minus. CH3COO is 1 minus, right? And magnesium is 2 plus. So we're going to need 2 of this guy. Okay, for 1 magnesium, you're going to get salt and then hydrogen gas, H2. And then to balance this, you would have 2 of this. Okay, right? Because you have 2 of these guys and you have 2 of these hydrogen. Okay. So the name magnesium ethanoate. Okay, the name is going to be magnesium ethanoate, and the formula is what I just wrote down: CH3COO2 Mg. Okay. State the name of gas E and gas F. Okay, so gas F is hydrogen gas. We just saw that. And gas E, acid and carbonate. Acid and carbonate react to form salt, carbon dioxide, and water. So the gas is carbon dioxide. The gas is carbon dioxide. The salt will be the same, magnesium propanoate. Okay, so this is carbon dioxide. This is carbon dioxide, and this is hydrogen gas. Okay, so we have to name it. So E is carbon dioxide. and F is hydrogen. And then state the name of ester G. Ester G is when propanoic acid is reacting with ethanol. We just want the name. Name में क्या होता है? Alcohol का नाम पहले, acid का नाम बाद में. Name, alcohol first, ethyl, right? Eth, so 2-carbon alcohol with a YL, right? And then propanoate, right? Ethyl propanoate. Okay. And then number 9. Okay, so describe the differences between addition and condensation polymers. Okay, so let me write them down, right? Addition polymers form when monomers combine, right? Monomers combine via addition reactions, right? Right? And no other products are formed. No other products are formed, right? Whereas condensation polymers form via condensation reactions. Okay, via condensation reactions where water is produced, right? Where the polymer and water are produced, right? So you don't get just a single product, you also get water being produced, right? That's one difference. And then the other differences are that addition polymers have the same empirical formula as the monomer. Condensation polymers have different empirical formulae. They have different empirical formulae from the monomer. Okay, and you would have addition polymers rely on just carbon-carbon double bonds, whereas condensation polymers you need two different functional groups, right? You need two different functional groups such as acid and alcohol or acid and amine, right? But you would always need two different functional groups, either in the same monomer or two different monomers, but two functional groups needed. Okay, two functional groups here, just one functional group here. Okay, so these are some more differences. You just have to give one difference, like, and state the differences and explain them. Okay, because obviously you can't write all of them. PET is a condensation polymer. The type of linkage, PET is a polyester. So the type of linkage is called the ester linkage. Okay. The type of linkage is called the ester linkage. A polymer contains 47.1% carbon, 6.5% hydrogen, 46.4% chlorine. Calculate the empirical formula. Empirical formula ke liye, you're going to take the atoms, carbon, hydrogen, chlorine, right? You're going to take their masses. Just take the percentages as grams. So we've got 47.1. We've got 6.5, and we've got 35.5. You have to divide by the atomic masses. Carbon has an atomic mass of 12, hydrogen is 1, chlorine is, oh, wait. Chlorine is 35.5, my bad. The percentage of chlorine is 46.4. Sorry, not my bad, right? 46.4, and then you get the moles, right? Because empirical formula is mole ratio. So we get 3.93. We get 6.5, and we get 1.31. Divide by the smallest number. Okay, divide by the smallest number, and you're gonna get roughly 3, 5, and then 1. So we get C3, H5, and then Cl. Okay. Plastics are made from polymers. Describe two environmental challenges caused by plastics, right? They form toxic combustion products. Toxic combustion products, right? When you burn them. And um, so they form, and specifically they're usually toxic gases, right? The toxic gases as combustion products. And the other one is that they accumulate in landfills or in oceans, right? Accumulate, right, in landfills or in oceans, right? Either one. Okay. Absolutely, it's great one.